Hi, my name is David, and I'm an applied scientist working at Amazon. Today, I'll be talking to you about my journey moving from bioinformatics to machine learning research and give some insights that will hopefully be helpful to you. So I want to introduce myself really quickly. I graduated from Princeton 3 years ago with a bachelor's in computer science. And during that time, one of my proudest accomplishments was co-founding the Princeton University Science Olympiad tournament, which some of you may have competed in. This year was the 6th edition of that tournament. And before college, I competed in Science Olympiad for 6 years. And during that time, I competed in over 20 different events. Some of my favorite events include Dynamic Planet, Micromission, Elastic Launch Gliders, and water quality. I managed to dig up a couple of photos from my competition experiences. So you can see that, like many of you, I had a very thick study binder, a couple of build events, and you can see a picture of my team. I want to give a huge shout out to my alma mater, Montgomery High School, because they won the New Jersey State Tournament this year for the first time since 2004 and are representing New Jersey at nationals. So congrats to the team and congrats to my coach, Mr. Sullivan. This is a huge accomplishment and I'm very proud of you. So now I'm working at Amazon as the machine learning research scientist, and my job is to develop machine learning models that understand videos and images. So what products at Amazon use machine learning? For example, there's Amazon Ring for home security. There's autonomous delivery robots. There's visual search for products such as fashion, the warehouse, and Prime Video, which are just a few examples of where machine learning is powering Amazon. And there's many, many different products that I didn't mention here. So what is machine learning? One way to define it is learning to perceive and reason about the world like humans do. So they're learning without being explicitly told what to do, and we're not programming them to do a certain set of instructions. Rather, machine learning is about learning from a large amount of data, and machine learning models now perform well in a variety of applications. One area of applications is called computer vision, which is a subset of machine learning concerned with understanding the visual world. So for example, you as a human understand that this is a video of snowboarding, and computers can also be taught that this is a video of snowboarding. Computers can also be used to detect brain tumors within brain scans, and they're also being used to detect other forms of disease and other types of medical images. Computers can also answer questions about images and video. And if you use Google, Facebook, TikTok, Instagram, etc., you know that these services are able to recommend similar images and video to you, which is powered by computer vision. Autonomous vehicles are using object detection in order to detect humans, cars, and other objects so that these autonomous cars can safely drive around without humans. And in robotics, computer vision is being used to reconstruct the 3D environment from a single image, which helps robots navigate around their environment. Another group of applications is called natural language processing, which is a subset of machine learning concerned with understanding text and language. So for example, machine learning can produce very realistic conversations now, generate text in a specific style, such as Shakespeare. And if you use Google Translate, you know that translation is getting better and better every day. And besides these, there's many applications outside of computer vision natural language processing. Machine learning is very ubiquitous and integrated into many products that you probably use every single day. And machine learning will continue to be an integrated part of life as machine learning gets better and better. So how did I get here? I had a very non-straightforward path actually, because in high school, I was mostly interested in biology and physics due to my experiences in Science Olympiad, as well as doing a few summers of research. So entering college, I wanted to do a PhD in computational biology. And during that summer, I did a summer research program at Harvard Medical School. And even though that experience was very fun, I realized that I was more interested in computer science because I realized the tools and algorithms from computer science could be applied to many different domains, whereas the things I was learning in bioinformatics were highly specific to a particular domain. And I found the generalizability of computer science to be very compelling. So I switched to computer science and I became interested in technology and entrepreneurship. I did software engineering internships at a startup and Amazon Web Services. And I also founded the Princeton University Science Olympiad Tournament and directed Hack Princeton. So I became heavily involved in the leadership scene on campus. Through those experiences, I realized I enjoyed building things, but I still wanted to be a part of research and create foundational knowledge. And specifically, I saw many powerful applications of machine learning, which led to my interest in doing machine learning research. So for my senior year, I decided to do a senior thesis. And even though I didn't have experience with machine learning outside of the classes I took, I was able to do a great job, and I won a outstanding thesis award, and I became co-author of my first paper in computer science. So after college, I started working at Amazon as a software engineer, and I was interested in converting to a research role. But the problem was a lot of research roles at Amazon require a PhD, and I didn't have a PhD. But I was able to find opportunities to do research, prove myself, and I eventually transitioned internally to become a research scientist without a PhD. So now I do machine learning research for a living, and I apply that research back to improve existing products. And so far, I've launched 2 features and published 1 paper as part of my Amazon research. So you can see that what I wanted to do before college and what I ended up doing after college were very different. And that's actually quite normal. So you might find that despite the plans you made, you might take a different path, and that's totally fine because change is very common at this phase of life, and you should embrace it rather than being afraid of it. So I've condensed my insights into 3 different slides. And the first one is that life is a marathon, not a race. I think it's useful to focus on enjoying the journey rather than the end outcome, because the goals are always changing. Once you achieve one goal, there's always another goal to achieve. So if you focus on the process of improving yourself, you're going to have a much better time. And I think there's a lot of different ways to get anywhere. So don't feel pressure to copy what other people have done. And their path is probably not going to be the same as yours. And I like to apply the concept of compound interest to experience. So whenever you build upon your experiences one by one and you learn from each one, you become better prepared to handle what's in the future. And you never know what might be useful. So if you think something is not directly relevant to your short-term goals right now, you should still try to do it, because learning a lot of things will be useful to you earlier on, and those might come in handy later. The second insight is to just do it, because I think a lot of the times we are the ones actually blocking ourselves. We might think we're not good enough, or other people don't want us, but those are not really the case. So for example, my senior thesis was supposed to be in an area of expertise, but I wanted to get experience in a new domain before I graduated. And even though I was a beginner in machine learning and computer vision when I started my thesis, I became an expert by the time I finished. And similarly at Amazon, I was not supposed to become a research scientist because I don't have a PhD, but I was able to do it. And that was because I knew what I wanted and I worked towards it. And at Princeton, I was told not to start the Science Olympiad tournament, but I still pursued it and it was successful. So I think the past does not dictate the future, and there's always exceptions to rules. So if you want to pursue something, you should just go for it. And lastly, I think technology tends to lag behind ideas. And one example can be taken from machine learning. So deep learning was invented over 40 years ago, but it didn't become popular until 2015, when both large-scale data and compute made deep learning more effective and more accessible. And in the short period of 7 years, it's now being used everywhere, even in chemistry and physics. And the 2018 Turing Award, which is the Nobel Prize for Computer Science, was awarded to the founders of deep learning. So this shows that the next big idea might not be popular right now, but that doesn't mean the idea is not good. Maybe it's the case that technology is premature, or maybe it's not practical right now. So maybe you, as a scientist, engineer, or leader, can make the next big idea become a reality. And since many of you are moving to your next phase of life, I thought it would be useful to share what I found most useful from school. And it's not any particular course I took, but rather the foundational skills and character traits, which I think will stay relevant even as the world changes and as my discipline changes. Leadership and communication are very important, because learning how to pitch yourself and what you do and why it's important will help other people see the world the same way you do. Regardless of whether you're in academia or in industry, it's very important to make sure that other people understand the work you do and why it's important. I think learning how to critically think rather than just memorize facts is important, because at school, a lot of the times we are taught a fixed set of knowledge, but that's not very helpful for solving new problems. So if you focus on critical thinking and problem solving, you'll be able to solve new problems using what you already know. And I think being very tenacious and resilient, which means not treating setbacks as failures, but rather opportunities to learn, is very useful. And learning how to learn is also very important because learning doesn't stop after you graduate. The world is constantly changing, so you'll have to be learning throughout your lifetime, and you have to be learning very quickly. So thank you for listening, and congrats again on making it to nationals. This is a huge accomplishment, and you are a winner for making it this far. So I'm very proud of you, and you should relax and have fun this week. I'd love to stay in touch, so if you want to chat, just feel free to send me a message. Thank you, and good luck this week.